Hello. So we're at the next stage of the Big Talker PCBs. PCB 1.1. It's dated just down here. I don't know if you're going to be able to read that. But yeah, so these are already populated with the capacitors, the Vactrols. I've put the wires in, hookup wires here. These are your output jacks. It's your power jacks, and unfortunately, just because of how it goes, those are actually your input jacks. This one is a bit of an anomaly, but it's a separate power connection for the switching mechanism, which I've put down here because it goes via this op-amp timer switch. And I've isolated that from the main power lines because you don't want to get switch pop. And it draws a little bit. It doesn't draw an insane amount of power, but it does draw a little bit of current. And yeah, so I've isolated that to a different set and the different part of the board. I think I'll change that on the next PCB design, but for now that's where we are. And then here is your expression pedal hookup. So now you can see over the board there's these three little dots. And those are our potentiometer connections. So what we're going to do is get our pots, spread the legs a little so that they set in there. And you can see here, there's no way of this connecting with there. It's pretty close though on that one, so I'm going to stick these on. Some of them are, obviously, some of them need them, some of them don't. For instance, the gain control down here sits here and you just don't need anything. It's just not going to touch anything. And of the connections underneath the board. So it's just not necessary. Obviously, you try and design your boards to not have to do that. Sometimes it's not possible, or it just doesn't make sense. And pots normally come with these little things, depending on who your supplier is. For instance, this one here doesn't hook up with anything. You can see it's pretty close there. I've forgotten which ones I do, in all honesty, so I'm going to stick that one on as well. Better safe than sorry. There's no need not to. In fact, if anything, it kind of makes it easier to install them later on down the line. So you can see. So those two are your speed controls, then coming in your depth controls. And there you go. And then your last two are your gain controls, which is A250. So you might be able to hear, I've got a bit of a cold still. Apologies for that, if that's upsetting you in any way. So yeah, I've got various value potentiometers here. And that's fundamentally it. Now you see those are hooked up. That's your speed, your depth, gain, and your bias for your LED. And flip that over. And again, as ever, I would normally, if I'm not making a video, have my extractor fan on, sucking away these fumes. I don't use lead solder. That doesn't make it totally safe. There's still lots of, I always forget the word in English, so I'll say it in German, Staub. Dust. There you go. Dust hanging around. You want to make sure those connections go. Sometimes when you've got a pot that's connected to the ground layer, it takes a little bit longer to solder it because you're heating a larger area. Somebody gave me a tip the other day on PCB design to try and get rid of that. And I think the tip was to increase the size of the direct pad there, so that once you've heated up the pad itself, it's more likely for the solder to connect. I realize the smoke's coming directly into the camera, so I don't know how hindered your your viewers. But yeah, this is where PCB design comes into play. And I'm reasonably happy, except as you can see right now, I need a little bit better access here. I didn't originally have this capacitor in the board because there wasn't ticking, but then somewhere after about 10 pedals I realized, okay, I need an extra capacitor there to tame that slightly. That's why I had those holes in there. Thankfully I did have those holes because it means that I didn't have to attach a electrolytic capacitor to an SMT op amp, creating the LFO. And it's critical now that you get all of these legs, of course, or you will have problems down the line. And you really got to check those connections as well. Make sure they're all happily soldered. Don't know what it is. Well, actually, I do know what it is. It's like I said. It's when sometimes your potentiometer legs are trying to connect to ground at the same time. So when these little things here, things that I've been soldering, when their pads are connecting to the ground layer, which is, I don't know if I can see. Stand up a second. Maybe easier on the back. See these lines here? This is a gap in the ground layer. So this side here is a ground layer for the LFO, and this is a ground layer, pretty much most of this side for audio, and then there's another ground layer somewhere there for the switches. But that is you call it star. Gosh, what do you call it? Star something. Star grounding. And you basically have little sections which are onto themselves grounded, like the audio section where it actually processes directly the audio. You have that as a ground layer, and then you have your LFO as a ground layer, and then you have your switching section as a ground layer. And it's sort of isolating your audio from your LFOs, from your anything that could kind of potentially put noise into the audio, which is obviously just absolutely not something we want at all. And so it's important to do when you have like a quite heavily populated board, which I'd argue this is a reasonably heavily populated board. You want to make sure that you're not kind of crossing over too many of the LFO sections with the audio sections. I think on one of the early external-internal prototype boards, I managed to cross a audio feed directly through the waveform section, directly through the LFO section of the board, and by goodness, it took me a long time to work that out. But as soon as I kind of cut the signal going from here all the way through the LFO section, you realize that, okay, I take it out, I cut that connection, make a hard wire, literal physical wire coming from here over the top, over to the output. Okay, yeah, we no longer have the ticking. And ticking is a really big issue for builders a lot of the time. It's a really hard thing to hunt down. Quite often, you don't know necessarily where it's coming from. Is it kind of something that's in the ground connections? Is it too much current from an LED? Is it directly from the LFO itself? You have to make a few compromises sometimes in softening LFOs so that they're not upsetting the rest of your audio signals. Oh, I've been a bit rough with that one. It's fallen out. Put that back in there. Apologies. So yeah, you can see now I'm soldering these again. And every single time I solder, if anybody's looking for soldering tips, got to keep the tip really clean. I used to suck at soldering. I was so bad at it. But just before I touch the component leg, I always tap it. Sometimes I don't necessarily have to. But it just puts a touch of solder onto your iron, which means that it can transfer the heat a lot quicker to the leg that needs to be soldered. If I don't do that, obviously it still works, but just makes it so much quicker, I find. Far less of a struggle to make that connection. There's always going to be legs, though, that are problematic. But yeah, I think on this one, I am going to consider making on this one and on others, I think an external internal too, as a very minimum. I think I'm going to look at making some socket PCBs. Because you see all the wires sticking out here. Take a while to cut and strip. And it takes a lot of time and patience, and it's not really for any kind of gain. And they're not even necessarily easier to repair. You can obviously see the physical connections of the sockets, the types that you can. So basically, the discussion is whether it's a PCB mounted or enclosure mounted sockets. And I am definitely considering moving to the PCB mounted style. But then you kind of don't want them on the main board, because the main board obviously moves around with every time you put your plug in. And once your plug goes in, the whole board moves potentially, and it moves other parts of the board, moves other connections, etc., etc. And kind of don't want to mess with your main board too much, especially with something as clunky as a big jack socket. Yeah, so I'm thinking about doing that. It kind of improves the speed of building as well, I believe. The problem is when you are drilling the enclosures, you have to be really accurate, because your sockets are no longer able to kind of have the wiggle room. So when you hand drill things, there's an amount of wiggle room, and you just are never going to get things absolutely perfect. As I tell my daughter, there's no such thing as perfect. But you're never going to get things perfect simply because you're doing it by hand. Even machines, aren't perfect, but they obviously can be a lot more consistent than you can with your hands drilling 20 machines as they get tired, drilling out 20 enclosures. And yeah, so it makes it difficult when you want to then mount your PCBs, mount your sockets on a PCB, and then you also still have to fit them through the same holes in your enclosure. So they have to fit through they have to fit through the enclosure perfectly and also into the PCB at the same time. So it is not a simple task to do. You got to get that drilling right. I've gotten a heck of a lot better in the last year, especially. I've started making 3D printed drill jigs, where you basically have a thing that you sit on top of the enclosure, and then you take your center punch, and it's got holes in this thing, this lid, let's call it, this jig. You just put your center punch in there, punch away, and create your place to drill. But then, of course, after that, you then have to take it away and drill by hand or slash on a drill press, which is what I use. But yeah, potentiometers. I know I used to have much bigger holes because I would put all of my potentiometers onto the enclosures. I know there was a lot of discussion about this with Death by Audio, or at least people talking about it on the forums and things, because every time somebody opens up a DBA pedal, they go, what the hell are these massive holes? And they look like this, actually, is what they look like. And it's these holes, instead of these tiny ones that I'm using for my pots now, you use these big holes. And it basically means that you can put all of these, mount them, and in addition to the switches, into the enclosure. And then you get handed an enclosure, because they're obviously working in, not in factory lines, that's not the right way to put it, but they are working, as part of a team. There's somebody who populates the enclosure, some people who populates the boards. Basically, you can kind of be handed an enclosure which is already populated with all the pots and switches, toggles, and yeah, and then you can just stick the PCB on really quickly. And I loved working like that, to be honest with you. But perhaps in my naivety, read those forums and saw that people were really upset of people working in this way, and so it kind of changed my saw some people doing it in a slightly different way. Thought, oh, that's also cool. So I slightly changed my way of working. They're both are valid, both are relevant. One does not get rid of the other, I think, so long as you're using enough solder, and both look good to me. Honestly, not bothered by that very much. But yeah, so this one's become more about PCB design, I suppose. This little video I'm making right now, and yeah, I'm always trying to improve the PCB designs. Always trying to make it better, both for sonic purposes, but also for build purposes. Obviously, when I'm making these things, if you're only doing it once, you say, oh, wow, that's annoying, but whatever. When you start doing these, and, I'm ordering 50, 100 PCBs at a time on occasion, simply because the costs of producing, 25 versus producing 100 are not vastly different, because it's a lot of the preparation time which costs. So yeah, so I'll order sort of, like I say, about 50, 100 boards at a time. And yeah, so you really notice the difference when you have made that change or you haven't made that change, because it's quite frustrating or annoying 20 times in a row every time you do a build. And I do about 20 at a time, pedals in a per run, roughly. Sometimes there's more reseller orders, sometimes less. And yeah, and after a while you kind of get into the flow of it, and it's not so problematic. And then other times you realize, damn it, I really must make a note. This is incredibly annoying. Please change the next run of board. So I have a list of 50 modifications to do across all the pedals. Change this capacitor's in the wrong position, and it's really annoying. As you can see here, I'm having to balance balance my wrist in weird ways in order to kind of get access to some of these. But there's obviously a visual aesthetic, which I, to an extent, feel strongly about. And at the same time, there's a practical considerations. You do not want to be messing around for no good reason. Yeah, I don't have a huge amount more to say on this one. I think you get the idea. These are your... I think I ran through what the cables are. I actually just realised I'm missing a couple of cables here. I might go grab those quickly. Obviously you make mistakes every now and then, but that's not one I could easily make and not rectify. Your input connections are quite important. Not sure I would have got past quality control without that, but who knows? Yeah, that's about all I've got to say about these ones for now. There you go. Big talker PCB populated with pots, capacitors, factorials, everything that makes it tick. Thank you for watching.